Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Quantum Balance by GDC or LM Damasi. We don't know which, it's one of the two. Anyway, here are the rules of the puzzle. We have yin-yang, where we need to shade each cell light or dark, such that cells of the same color are orthogonally connected, and each 2x2 area contains both colors. So this is an example of a valid yin-yang shading. And what it means to be orthogonally connected is that any cell from any of the blue region, or the shaded region, I guess he has light or dark. But any of the cells from the shaded region have to be able to go to any other cell in the shaded region just by going through edges, all while staying within the region. So for example, to get from this cell to this cell, you can just go here, and then here, and then here. And that would be all through edges, all while staying within the shaded region. Same with this region. To get from this cell to this cell, you could go here, here, not there, here to here to here, and then basically that would be all traveling through edges, all while staying within the region. This is not a valid pattern because this cell cannot travel to the rest of the unshaded cells, or I guess the light cells, through just going through edges, all while staying within the light region, right? It would have to go through a corner, or it would have to travel across the shaded region, or the dark region, which is not allowed. This would not be valid because we have a 2x2 area, which does not contain both light and dark colors. So for light, I'm going to be using green. For dark, I'm going to be using blue. Anyways, that's an example of how yin-yang works. We also have Shrimdoku. Shrimdoku. I don't know how to pronounce it. It's Schrödinger with M-doku. I don't know why we have an M-doku, though. Shouldn't it be Shrimdoku? I don't know. For each light cell, so let's fill out this as a light region too. For each light cell with a digit, fill each light cell with a digit 0 through 9, and each dark cell with 2 different digits 0 through 9, such that row n and column n contain exactly n unique digits. So row 1 must contain exactly 1 unique digit. So does column 1. Row 9 and column 9 must contain exactly 9 unique digits. Interesting. That should tell us something. So, anyways, we have equal split lines, where dots split lines into segments with equal sums, and digits don't repeat on segments. Okay, that makes sense. So, the sum of the digits on this segment must equal the sum of the digits on this segment, which must equal the sum of the digits on this segment, which must equal the sum of the digits on this segment. Obviously, there's going to be some things that we have to change, but interesting. Huh. So there is no requirement that obviously. So, but the only requirement that we have for uniqueness is that row 9, column 9 must have 9 unique digits. Row 8, column 8 must have 8. Row 7, column 7 must have 7, etc., etc. And then we have equal split lines, where dots split lines into segments with equal sums. That's very interesting. Anyways, and digits don't repeat on segments. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so every cell can contain with 2 different digits. Oh, whoops, I forgot, I didn't say. Maybe I did say it, I didn't emphasize that. So, interesting. Because row 9 and column 9 cannot contain, they have to contain 9 unique digits. That means you can only have 1 digit that's repeated here. Since, I guess you could, you could technically have all of these be blue. Technically. Well, okay, so these are green. These are definitely light because there's single digits there. But technically, the rest could be all blue, right? Because you could have the same unique digit be in all of the blue, right? Or, sorry, the same digit be in each of these cells, and then the remaining digits contain the digits like 1 through 9. So you could have 0 be essentially the repeating the digit that's repeated, and then every other digit be contained. But we know this is equal to the same sum as this, which is equal to the same sum as this and this. So this cannot fit that criteria here. So that means, right, because if they were both blue, so say they were both blue, that, and because there are 9 unique digits, the 1 digit that has to be repeated must be in both of these. But then they wouldn't add up to the same sum, right? Because they'd have the other digit be different. So that's not possible. So in this scenario, I think you have to have one of them be green. At least. And if we tried going green all the way around here, so one thing we're guaranteed is in row 1 and column 1, we are guaranteed there's going to be at least every digit must be duplicated except for 1. That's 20 minus 1. So we are guaranteed we have to have 19 digits in row 1 at least. Yeah. And it could be more. So we're guaranteed at 19 digits. So I think that means we have to have blue all the way here. And it could extend further. This could be blue here. Now, the thing is about yin-yang shading is if you swap from one to the other, you always have to swap. You can only swap one more time along the edge of the grid. And so basically, so let's make this essentially, this is blue. So if we try to essentially shade this green and then this blue here, this does not work because if you try to orthogonally connect all the greens, you would necessarily cut the blue region into basically multiple regions, which is not allowed because you only have one orthogonally connected region for the light and one orthogonally connected region for the dark. So since this has to have at least 19 digits in it in row 1 and column 1, that means all of these cells are blue. We know, again, one of these is blue, one of these is green. because they can't be adding up. They can't be blue and blue here. So this must be green, because if this is green and that's blue, then we'd have the problem of swapping to green and then swapping back to blue and then swapping back to green. And then these would be orthogonally connected, which would break the blue apart. So this must be green, that must be blue, so this has to connect this way as green. This must be blue here then. We have 3 blue cells here in this 2x2 area, so this must be green here. These 3 digits have the same thing. Actually, that's not true. Never mind. So another thing about yin-yang shading is that if you have 2 of the same color in one region, wait, that's not gonna work. Ooh, ooh. Huh. That's problematic. We know one of these has to be a blue. This is funky. So the problem I'm running into, okay, so if you have 2 shades, so this is green. If you have 2 shaded cells that are diagonally opposite of each other, you cannot have the opposite color here. Obviously, you can't have the same color here, because then that would be a 2x2 area with just one shading. But if you try to have opposite colors and then try to orthogonally connect them, the problem is that would break the other region into 2 separate regions, which is not allowed. So this must be green, but this is the same, this sums up to the same sum as these 2, which is impossible for green. So that's not going to work here. Oh, interesting. Right, we never mind. So okay, so we could have 2 blues here. This could be 2 blues. In fact, okay. Yeah. Wait, can we? Yes, we could have 2 blues. Interesting. Or it could be 2 greens. Hmm. So I was going off of, yeah, because I was thinking of normal Sudoku rules, but this is not normal Sudoku rules. You have to have repeats actually in every row, column, and box. You just have only 1 repeat in column 9 and row 9. You have 2 repeats in column 8. 2, and those are 2 digits which can be repeated. So this technically could be all blue. We can't have green, green, green. Or could we? We could have green, green, green there. We actually don't know if this could still be 2 blues. So okay. What I'm thinking is that, oh, this is funky. Oh, wow. Huh. So these sum to the same sum in these cells. they could just be the same digit, right? So it could be all green here. Obviously, one of them has to be blue because you have to have both colors in a 2 by 2 region. But, so this is still definitely correct. It's all blue here and all blue here. It could extend blue here. It could go all the way here, right? This could all be blue technically. Um, but it could be blue and green here, right? And then this is green, green, green. So then again, like this space would work that way. But these could all be the same digit, which is allowed. Oh, that's funky too. We only have two unique digits in row 2. So we must have 8 repeated digits. So this is guaranteed to be green. In row 2, we have to have... Oh! Wait, hold up. Okay. I've been thinking about this all wrong. You don't have to have... These could all technically be the same digit, so it could be all green here. Oh, okay, so this is not guaranteed to be all blue. Right, you don't have to have the digits once each. And in fact, you can't. Because the way that the shading works, if you had something shaded like this, and you had to have every digit included in row 2, from 0 through 9, then that would be a problem. But you don't. So these could all be the same digit, technically. You just have, you just have to contain exactly n unique digits. But you don't have to have it filled out with all the digits from 0 through 9. Which then does not mean you have to have 19 here. It just means that you have to have things that pair. We have only one unique digit in row 1. So column 9 and row 9 are definitely, you have to have 9 unique digits. But that means the 10th one, there doesn't have to be a 10th one, but if there is a 10th one, it has to be duplicated. Okay. That's funky. Right, because you don't have to have the digits 0 through 9 appear at least once each in every row and column. Since we don't have that constraint, we can just basically leave some out. But these cells sum to the same sum. It cannot be... One of them is guaranteed to be blue. You cannot have 2 greens. I mean, technically you could have 2 greens here, and they both be the same digit. But the problem is... I guess? The problem is you would need a blue here, because there are only 9 cells, right? If all of these were green, the problem with all of these being green is... I mean, you could have all of them green. And that could work, because then you'd have 9 unique cells in the column. But the problem is these two have to add up to the same sum. And since these two must add up to the same sum, that means they must be the same digit if they're both green. So then you would only have 1, 2, 3, 4, 5, 6, 7 unique digits if these were both green and you didn't have a blue. So you're guaranteed a blue in column 9. You are not guaranteed a blue in row 9 because these could be all green, right? Um, Interesting. Okay. One of these 2 by 2 boxes is blue. Um, hmm. Oh, that's funky. That is funky. Oof. Yeah. I've never run into this Sudoku, so I don't know any of the implications right now. So I'm just trying to figure it out on the fly right now. We have equal split lines. So technically these could all be the same digit, right? It could be all green. We just don't know. We know one out of this 2 by 2 area is blue, one out of column 9 is blue, but that's all we really know. You could technically have all green here, and this would be the same digit except for 1, right? That's possible. Same with column 1, right? This could all be green with everything the same digits, or everything repeated or duplicated except for 1 digit. Hmm. Huh. Okay. Hmm. I'm pretty sure we have to use this to basically try to disambiguate things. I'm not sure how, but I'm sure that that's part of it. Because this is very unique, right? We don't have very much in row 1 stuff. We don't have very much in column 1 stuff. Um, um, hmm, hmm. We have 9 unique digit here. Yeah, it's got to be something related to this because these two are the same sum. So either they're different digits adding up to the same sum, or they're the same digit. Hmm. If they're different digits adding up to the same sum, hmm. That would mean it'd be. I mean, that's quite possible. What happens? Okay, so what happens if they're both green? If they're the same digit? We are guaranteed a blue somewhere. I mean, it could just be here, right? So, well, how many blues would we be guaranteed? This is the same digit. We're guaranteed at least 2 blue digits, if that's the case, right? Because if we had this is 1, 2, 3, 4, 5, 6, 7 cells, we need 9 unique digits. These are the same digit. Huh. Interesting. Huh. Okay. My intuitions are not getting very strong here right now. Hmm. That would mean there's at least two blues. You could have just two blues in the middle, right? Um, okay, we don't. Hmm. 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 Uh, hmm. Yeah, I'm kind of not getting this right now. I'm not. Hmm. Okay, let's mark the same sums. We'll basically, for single cells, we'll mark those as like pink. So these are the same sum. These are the same sum. These two are the same sum. 1, 2, 3 are the same sum. This is different, so this is the same sum as this. We have that and that, which is the same sum as these three. These are the same sum. This is the same sum as these two. These two are the same sum. Huh. But these are different same sums, so maybe we should mark them as unique. So we can't use blue and green. I guess we'll make that medium. This will be dark. This will make pink. Orange will be here. So orange and orange. These will make red. Actually, we'll make this red. This will be yellow. 1, 2, 3 are the same sum. And then these two are the same. Okay, so we'll make that light. And then this is, we're missing a color. Huh. This is the same as these two. Hmm. Interesting. So this is a unique number color. Oh, this is the same as that. Huh. That's quite a bit that's the same. Okay, I guess we'll make this brown. So that's actually very important. So this is the same sum as that, which is the same sum as that, which is the same sum as that. Ooh, that's interesting. Huh. What does that tell us? So technically, brown could be the same digit and dark could be the same digit. And then they're basically, those are the rest of the digits must be unique. That's possible. Hmm. Hmm. Uh. So this red is not very helpful. Let's make the brown essentially the red. And then we can just mark that these are like A and A. Yellow can be useful. Pink could be useful. Orange, not really that useful. Light's not really that useful either. Though light plus something equals red. Right? And light plus red plus something equals orange. Hmm. But you could have 0 here too, right? Yeah. So row 1 and column 1 don't really tell us much. It's really, I think, row 9, column 9, or row 8, column 8, which might tell us more information. But I don't know. Exactly in unique digits. Wait a second. Hold up, hold up, hold up. No, 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 no. Okay, I've been reading it all wrong. It's that you have to have. Right. You can only use 9 digits in each column. In column 9 and row 9. You can only use 8 unique digits in column 8 and row 8. You can only use 7 unique digits in column 7 and row 7. Row 1 has to contain the same unique digit, and column 1 has to contain the same unique digit. Interesting. Okay, that's right. So that's a different way of interpreting it. Hold on, let me double check that this is the way that it's supposed to be. I'm gonna pause for a little bit. Okay, and I'm back. Yeah, so that means, yes, I was misinterpreting the rule. So I read it correctly, I just didn't interpret it correctly. These all have to be the same digit, or contain the same digit. These must all contain the same digit. These must contain what's in digit column 1 and another unique digit. These must contain what's in row 1 and another unique digit. Same with these. So this is 3. So you're adding one unique digit to each row and column respectively. So actually, This row 1 and column 1 is kind of important, actually. So these are all the same digit, guaranteed. Let's make this Z, I guess. And this could be multiple ones of them, though, as a Schrodinger. Or Shroom, yeah, whatever it's called. Shroom, maybe that's why it's Doku. I don't know. But these are all the same digit. But you could have multiple ones. You could have two A's, right? So that's not necessarily just all A's. This must contain A and a B. So these are all A's, or contain A's. This is A and B. These are A, B, and C as possibilities. These are A, B, C, and D, with 0 being one of those. These are A, B, C, D, E. These are A, B, C, D, E, F. Oh, interesting. Every row... So because of the way that it works... Every new cell... Ah, interesting. So these can only contain A. To have 9 unique digits used, you have to introduce a new unique digit in each of these cells in column 9 and row 9. Huh. So this is either A plus B or it's B by itself. This would have to be C and... Huh. That's funky. So we're guaranteed to have a B here, a C in each of these cases, a D in each of these cases, an E here. This is F. So 2 is F. So we're guaranteed a 2 here. We have G here, H here, and this has to be I. But with Schrodinger, we don't have to have that add up exactly correct. But these are guaranteed. These digits are guaranteed in each of these cells. At least one of them. We could have multiple 2 up to there. And you can only have 2. Our dark cell with 2 different digits. So obviously B cannot equal C. But A and B could equal C, or it would have to be B and C cannot be the same digit. B and I guess you could have 2 different digits in Schrodinger. So it cannot be B and B. So you have to have A and B equals C, or A and C equals B here. Interesting. Huh. So F is 2. We know that for certain. We don't, so that means we are missing a digit in the entire grid. Okay. So this must be some combination of A, B, and C here. This can't be C. This could... Okay, so this is A. This could just be A and... A is never going to be... I think this has to be AAA, right? But it could be 0 with it. Hmm. Um. Oh, so these have to be green. These are guaranteed to be green. Funky. These have to be green because you have blue must contain two distinct different digits. So therefore these all have to be A and therefore are green. So these are guaranteed to be green. This is A. So that has to be the case here. So this is not medium. That means this is blue. And here, we know we gain a B here. We gain a C here to make sure that this has unique digits. I mean, I guess technically this could be... Oh, that's not true. We are not guaranteed that. We are not guaranteed each digit comes up once here. Because it could be just like A's throughout here, and then basically you have multiple blue cells here. Right? Interestingly enough, this is green, though. So since this is green, that means it's either green going this way or green going this way. If these were all green, then you would have to have one of each unique digit coming up here, right? If it's not green, so say this is all green, then. Can this ever be all green? I guess. Okay, if this is all green, then this would have to be, like we said, A, B, C, D, E, 2, G, H, I, right? And then these would have to be unique digits, H and G. But we could have multiple blues here, if that's the case. Obviously, if all of these are green, these two are the same digit. But they could be B and B, technically. Or A and A, potentially. If that's the case. This could technically be A and B if it's just if B is 0. And one of the digits in the first 4 is going to be 0. One of the digits of the first 6 has to be 2. Oh, interesting. This is at, well, it could be A and B here. Hmm. Well, if A is 0, then these all are A. So what would that mean then? This would have to be blue, blue. That would mean this is A and A. So what happens if we have this as A and A? Then the blue has to go out. This must be blue. So this is A and B. It has to be A and B. That's A and B. This would be A and B. That would be A and B also. Hmm. Hmm. Interesting. Okay. Here, at least one of the pairs. So one of these two must be blue. You could have potentially both being blue. So one of these is guaranteed to be A and B added together. And it could be both. So the only way that works, so the only way this is one green and one blue is one of these is 0. Right? Because then essentially AB would equal B or AB would equal A. And you're guaranteed that they would be equal to 0. So then this could be blue if that's the case. Um, or they could both be blue. Hmm. So if none of them are 0, this would have to be both blue A, B, and they would have to add up to C. I guess this could be A and B here, right? Oh, that's interesting. Huh. If that so okay, let's say that was both blue. That means green would have to be all the way around here. So this would be green. This would definitely be B, C, D, E, 2, G, H, and I. And this would be H and G to add so that we have 9 unique digits. This would have to be E, D, and we would have to have C here added. But these could be blue. So this would be AB. AB and AB added together. We're... Hmm. This would be blue. So then this would be A and B. This would be blue. But we don't know what that would be. This would be blue. Okay. Well, actually, one thing we do know is that's blue, period. So let's not do that yet. Let's make this blue. So this is A and B. We know that for certain. So we're making this both blue, and then that makes this AB also. This is guaranteed then to be all green. So again, we would have B, C, D, E, 2, G, H, I, then H and G. Would that be 2? Maybe that would be F, right? 2 could technically be any from A through E here. This would be blue as an AB, though. Hmm. This would be blue. So it could be 0 and G, technically. Hmm. So this is the assumption assuming neither A or nor B are 0. And we're also assuming that this is an AB pair. Well, actually, no. We have to assume this is then. So because neither A nor B are 0, you can't have A equals AB or B equals AB, and one of these has to be AB because one of them has to be blue. So because of that, that means these two have to be the same, and it must be two blues, which means the rest of this is green. That forces this to be blue, this to be blue, so it's AB, AB. Hmm. This is not possible. This is not possible because then G would be the same as H, and that's not possible. Okay. That means 1 out of A and B is 0. Right? So this is H. This is the same as G, but they are in different digits, which is so, and there's only a single digit here, so therefore that's not possible. So we cannot have. So that's the thing. Any of these cannot be blue. Because if any of these were blue, that would force this scenario again. And again, you'd have H equal to G, and they are definitely different digits. So this has to be green going all the way here. And because this is green going all the way here, we don't have a guarantee that these are all the same digits, right? Because again, we have to have 9 unique digits in column 9, but they could be different. Well, they're basically 1 out of A, B, C, or... So this is 1 out of A or B. This is 1 out of A, B, C, A, B, C, D, A, B, C, D, E. But you could have blues here, right? All along here. So this is basically not restricted. You have to sort of have blues. Well, okay. So if this is green, that's not going to work. Because if this is green, so this can never be... If this is green, it could be green as long as these are blue. So both of these cannot be green. Because if both of these are green, all of these are green. I guess you don't have to have... No, okay. So the problem was, essentially here, was if this was blue, right? If any of these are blue, this must connect all the way here. Oops. We do know that this is blue, period. So this is AB. If any of these are blue, the problem is all of these would be green. And to have 9 unique digits here, it would have to be a distinctly different digit here, right? And this would have to be the digit B, which is added in column 2. This would be C, D, E. That would be F, G, H, I. And these... Where would you get G, H, I in columns? In one row through 1 through 5. You can't. Because basically, B is only available in... Well, can these be different digits? I don't think so. Maybe. Maybe these could be different digits. In which case, these are not matching. Huh. No. Okay. This can't. No, you can't have. You can't have it. Well, can you? No, actually, maybe you could. This means B has to be the same ones here, right? So these have to be the same guaranteed because you have a blue cell only in row 2 and column 2. But you're not guaranteed that along each diagonal. So these digits don't necessarily have to be the same as these exactly. Hmm. But because we have an A-B pair here, which has to be A and B. Oh, technically this could be AB2 also here. Hmm. Okay, so that's not a good assumption to make. So these could be like all AB here, and we're not guaranteed that they're the same digit. Interesting. Well, this has to be a unique digit each time. So this is guaranteed B, C, D, E, E, F, G, H, I. So this would have to be the same as that digit. So this would be H. This could not be G. Oh. They don't have to be necessarily the same unique digits in column 9 as row 9, right? We have 10 digits total, but these don't have to be the same digits. This is definitely adding B. So that's definitely going to be the same, right? Because this is A and B. So A and B have to be available in row 2 and column 2. But starting from row 3, column 3, they can be different. We know this is H. We know this is H. this must be blue. It must add up to G. This cannot. It could be H here. This digit cannot be I, or it cannot be G or F, because I with some other digit must add up to H. And these are distinctly different. It could be I and I adding up to H. It could be, say, I and 2 adding up to H. This is blue, so it would be A and B. Uh, huh. This is tough. Yeah, the logic of this was I did not really understand the logic of this puzzle throughout. Um, as I said, it's the first time I've run into this Sudoku, so that's interesting. It's similar to there's a different type of puzzle I think that was similar to this, but not completely like this. It had basically that you had certain unique digits, but you didn't have Schrödinger cells here. It was just basically you had to have a certain number of unique digits in each row and column. So I did run into that. Um, so this is definitely A, B in that instance. This is H and H. You could have a J here, actually. Hmm. So this could be the case. This could actually be an H here. That's possible. But okay, so then either this is H or this is H. This could be the sum of anything. Hmm. We are guaranteed this is A and B. Ugh. Okay. Yeah. So this was all assuming that A and B were not 0. So then this would have to be AB. Um, it would have to add up to C somewhere. I guess this could be AB here. Hmm. So these are AB possibilities here. This would have, okay, so this would not be A and B. It would have to be just A. Because neither A and B are 0. So the blue would have to go out here definitely. We'd have to have one out of blue in one of these three at least. This would be blue, so this would be AB. We'd have to have a C, or it doesn't have to be C. It could be some other letter, right? So this would be, the sum of these would be A plus B. So 2A times 2A plus B. That means one of these would have to at least be 0. And you'd have to have an A. Can it be all? I mean, you could have 0 with all of these, with A and B. So this would not be guaranteed not to be the other digit. Or it could. Oh. No, it cannot. Okay. It cannot be this other digit. So we're guaranteed 0 in one of the first 4 digits in rows 1 through 4. And 0 in one of the first 5 digits in 1 through 5. Whichever digit is here, I guess we'll make it X. So it's not guaranteed to be C. One of these has to be X. So the sum of AB, one of these could be A and B, and the other one could be X. And in fact, I think they have to be. If it's green, green, how does that work? So say these are both X. And then blue goes out here, that's AB. Or I guess we can make this Z. Let's start with Z then. Z and then Y, then X. So it has to be added somewhere here. AB, AB, Z, this has to be blue. So technically it could be like that. Then this becomes AB or Z. This cannot contain Z, so it could be AB. So Z, so that would force 0 to be the fourth one here. So this would not be Y. These would all be green. Oh, that doesn't work. This cannot be 0. It would have to be one out of A, B, or Z. But then we wouldn't have 9 unique digits, right? You can only have A, B, Z, or 0 in row 4. Because you only have 4 unique digits. And you have the guaranteed A, B, Z in rows 1, 2, and 3 here. Well, not technically. We are guaranteed A, B, and 0 here. This could technically be another Y. Okay. So we'll keep trying then. Therefore, this is blue. And this is guaranteed to be A, B, or Z. This would have to be A, B, 0, and Y. This would be A, B, 0, and Y. Um, Y couldn't... actually, it could add up. Ooh, depends how big 2 is. But Y can only be... Okay, so Z would be the sum of A and B. None of these could be 0. So this can't be Y here. This is blue. So it could be 0 and A or something along those lines. Hmm. So this would be X, this would be W. So that's assuming this is, yeah. This would be AB. Hmm. This would probably be 0. So could it be A and B? That would mean this is exactly the sum of Z. Y. Yeah, Y is going to be the sum of 3 digits with A, B, and 0, possibly. So it's at least A plus B. Or I guess it could be 2A, technically. Hmm. So B could actually technically be larger than Y. Or 2A, 2B's here, which would mean A would be technically larger than Y. So that's possible. Huh. Huh. I mean, it's. I don't know if we're getting into any more restrictions. That's the problem. Uh. I mean, technically, this could be green, green, green here. And then the blue would go out that way. Hmm. Yeah, the Schrödinger really adds a really tough component here. You would have blue going out that way. So this would be A or B. This could be 0 with something. One of these. So well, Y could be less than that. Ugh. It's always that case. Y could always be less. Hmm. So but the thing is it doesn't have to go that way, right? That's the issue. Okay. So if A, B are not 0, Z cannot be 0 here. Because the new digit would have, it cannot be both blues, so it can't be A, B added together. And they have to be distinctly different digits to be in the blue. So A, B could be added together, but it has to be with another digit here. So this would be Z. Um, hmm. So that's if A and B are not 0. That would mean Z is not 0. That means 0 would be the fourth digit added in row 4. Actually, this doesn't really have to be added, right? Because you could have another one different. We just know we have to have A and B definitely in that scenario. Because we are guaranteed this has to be an A-B pair. And again, we're making the assumption A and neither A nor B are 0. Z then has to be non-zero also because it must be the sum of A and B, which are non-zero. Therefore, this cannot be a sum of A and B, so these would all have to be green in the single digit A. Could not be single digit B because that's different from A. A and B added together adds up to greater than A. And Z is equal to A plus B. So it could not be a single digit Z. It cannot be the sum of A and B and A are different. So that's the reason why we have all A's there. Oh. But then we get kind of stuck, I guess. Y is a different digit than Z. So because these both have to be, we are also making the assumption this is green, green. I don't know if we want to make that assumption, but we're going to do that. But so far, it's not reaching a contradiction. That's what I'm trying to look for here, to disprove one of the paths down that which we could go down. Could go. Yeah, we don't. These digits do not have to be the same exactly as these because again, we have the Schrodinger's, which is throwing things off for a loop. So again, I've done puzzles kind of similar to this in the sense that you have to have unique digits in each of the rows and a different amount in each column. I haven't done it too often, so it's not very common. But the problem is I haven't done it with Schrodinger's involved, which means we add another digit, possibly. So yeah, so that's an issue. Um, and the problem is this is going down just one path, right? I haven't even ruled out that the green goes this way, and then these could all be blues. And that leads to another headache too, potentially. Ugh. But this is not leading anywhere right now, which is kind of problematic. Uh, hmm. Oh, digits don't repeat on segments. Digits don't repeat on segments. That's very important. Okay. So this cannot be. So A and B cannot be. One of A and B is 0. And the reason why we know that is this cannot be blue. Because if this is blue, it contains both A and B. Oh, I guess it could contain B and C. No! No! Okay. Maybe we can do this. Maybe this can be okay. Digits cannot repeat on segments. That's actually very important. Okay. So, assume A and B are not 0. So this has to be an AB pair adding up together. This then has to be A and A. Because, again, so this has to be A, which makes it green, which makes this blue. No, it has to be A and B. Because the only different digits you have in column 2 are A and B. You can't have a separate set. So yes, that does prove either A or either B are 0. Okay, yeah. So that was important. The digits don't repeat on segments is very important. Because the problem is this can't be AB as a Schrodinger. But if it were, the problem is you would have a repeat here. This is guaranteed to be green. And so it cannot be A. This has to be B, which is the digit in column 2. So this cannot be A or B must be 0. Guaranteed. Because if it's not, this has to be AB as a pair added up together. And that cannot equal a single digit. So they would both be blue, which would then have to add up to a single digit C here. So these still could both be blue, but one out of A or B is 0. And because one of this has to be blue. And it must be A and B. And again, then we have A and B is equal to A plus B. Oh. Interesting. So this could be green or could be... So that means A, whichever one of A or B... So that means this is, again, A and B in some sort. These are guaranteed to be A and B in some sort. You could have... One of these has to be... This definitely must sum up to the non-zero out of A or B. And since it sums up to the non-zero out of A or B, we are given additional digits here. But this cannot be C. It has to be some combination of A and B. Right? Because, again, 1 out of A or B is 0. You can't, if you have a Schrodinger, you have these different digits. You have to have 2 different digits. So it can't be just C and C together added up. It has to also be A and B here also. But we don't know if this is... One of these has to be blue. We don't know which. It could be green here. Okay, so let's remove that assumption, the green assumption. This is definitely not blue. It has to be green. So this is B. A and B here. This must be blue then, which means this must be AB, because that's the only possibility in row 2. These have to be some combination of A and B, which essentially adds up to the non-zero out of A or B. So this is A and B. C cannot be A or B. We are guaranteed an A and B in this row. So this could only be A, B, and C, quote unquote. Though this, I guess, could be a different one. Maybe we'll make this Z. So if we have Z here, the problem is it cannot be the same digit as A or B, but we know this digit has to be the non-zero version of A or B. So either A or B is 0. We have guaranteed that because we have A equals AB. So that's certain. The Z cannot be here because, again, anything with that digit cannot equal that digit if it's not 0. And we know it cannot be 0 because one out of A or B is 0. So therefore, Z is non-zero. If it adds up to 0, it would add up to itself, but not the other digit, which it has to be different from. And if we have, so this must be essentially an AB pair. That's interesting. Which means we guarantee, we guarantee have to have a blue somewhere here. It could be one of these two. We are guaranteed only 3 digits here then. And one of them is 0. So we have to have at least one blue here. Or we could have blue here potentially. These are... We're going to make this... Okay, so Z... And then we're going to make this Y, X, W. This will be I still. W. We'll make that V then. Okay. So this, again, cannot be the Z that's in this row. So it has to be... some combination of A and B. It could be green by itself. We don't know which. It could be A, B combined. That works. It can't be C because, again, C is different from A and B. And therefore, it's non-zero. So plus 0, it would be itself, which is not summing up to the same sum as the non-zero A or B here. And similarly, if it adds with the non-zero sum, it would be not equal to that sum, so with that digit here. These... So this is some combination of A, B. We don't know. So we have a Z somewhere here. Obviously, these are combinations of AB. These are combinations of AB. You can't have A here. So this cannot be blue. Because, again, that would force that to be AB pair. So this is blue and... Sorry, not blue. Green as a single digit and must be B. This can't be A or B here, so this must be C. Because, again, you can't have repeats in the segments. So this is C. So we have A, B, C here. Interesting. These digits must be... Oh, there's no repeats here. There's no repeats here. Along this entire segment. And it's 4 cells long. If we try to not have green there, it's not going to work. So this has to be all green. Interesting. Right? Because if it's blue, we are guaranteed to have a repeat here because there are 4 unique digits in these 4 rows. Right? You can only have 4 unique digits here. So these all have to be green. Interesting. Which means obviously Y has to be one of these 4. We don't know which. Since these are all green, this has to be blue. This has to be blue. This blue must exit out this way. So this is blue going there. So this has to be green here, which means this is... So A has to be the non-zero. B has to be the 0. because if A were 0, that means A would equal 0 plus something else. 0 would equal 0 plus something else, which is not allowed. So A has to be non-zero. B has to be the 0. So all the B's are 0. So these are A and 0. These are A and 0. This must be blue because of the 2x2 area that's all green. That makes this all blue to be going out because of the 2x2 area. Actually, the blue has to be orthogonally connected to the rest of the blues. So this is A plus C here. This must be some combination of... So Y... So we have 0. We have A, Y, Z, and 0 in these 4 cells. Again, you cannot have repeats on segments. That's very important. So that's very important here. This is 2 unique digits. I think that's forcing this to be blue. If we had blue, say this was green. If this is green, we have only 4 unique digits possible here. But blue has to get out somewhere to connect to the rest of the blues. So it could go something like funky like this, but then the problem is these are 4 unique digits. And there's only 3 unique digits possible in row 3. Because, again, digits don't repeat on segments. So that's a contradiction. So Y has to be a blue. Or this cell has to be a blue. And it's likely Y was something else. So since blue is here, that does force this to be W, or all green here. So this is all green. That makes this 0. So this is 0. We have C, D, E, F, G, H, I. This must be the same as this one. So this is H. And this is a V. This has to be blue. This is blue. So this is a 0A pair, a 0A pair. Okay, so B, okay, so this is A. 0 and A add up to the same sum. This is G, this must be blue. So it adds up to the same sum as G, but that doesn't tell us much. This is blue. H and H, and that sums to H. So V and I sum up to H. G and F sum up to H. So A cannot be on here. We have 4 unique digits on here. A cannot be the unique. That means we have to have another unique digit here. Oh, funky. I guess we'll make it W. This is A0 or... So this has to be 0 or Z here. Specifically, right? This doesn't have to be Z. In fact, yeah. This cannot be A. I guess it could be Z, technically. This can only be 0, A, or C. it could be 0 or C here. So we don't know what Y is. This could be 0 or C. So the Schrodinger really makes things really strange. Hmm. So one of these is going to have to be blue because you have to get out for the blue, and if one of them's blue, the other one's green. So this is a blue-green pair here, definitely. Which means if this is blue, that must be blue here to get out. If this is blue, obviously one of those is blue. This is green. I think this has to be blue either way. So if this is blue, this is green because of the 2x2 box in the area. So the blue must get out and it has to go here. If this is green, this 2x2 area has 3 greens. So this has to be blue. So either way, this is blue. So that's blue. Interesting. Okay. So if this is 0, this is C, and one of these is 0. No, it cannot be. Oh. Okay, so this can't be 0. If this is 0, that makes this C. And we'd have A0CWY here. So this has to be Z here. This is some combination of A, Z, and C. If we have 0 here, it could be W and Y. We're guaranteed one of these three is a 0. So I think it has to be Y and W. And C is either W or Y. So Z cannot be here at all. This is a combination of 2 digits. Well, this is a combination of 2 digits also. C could be a 2. A could be 2. We don't know. So this is guaranteed to not be Z. So W is not the same as Z. Okay. This is some combination of 0A or Z. 0A, oops. 0A or Z. This is some combination of 0A or Z. Again, this is 0A or Z. Oh, it has to be... This has to be... Okay, so this cannot be 2 blues. Because again, that would be 3 unique digits. Sorry, 4 unique digits in the same segment. So this has to be green. This... I guess it could be blue. Anyways, blue has to go out here. Which means blue has to go to here. This is 0A, 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 0A. These are diagonally green, so this can't be diagonally blue here, so this must be green. Blue has to go somewhere to connect, and it has to go through here. So this is blue also. So this is the same sum as this, but we don't know what it is. We have a blue diagonal here. Okay. So we're guaranteed a 0A and a Z here. This is a single digit. We don't know. So A must be the sum of W, Y, and Z. Okay. A is also here. That's interesting. So this could be A plus Y, and that would actually be somewhat valid. If it were the case, though, if this were A plus Y, the problem is we need another unique digit, so this would be blue. Say it's not A and Y. This would have to be a different digit, right? So this is, okay, A is the sum of 3 unique digits. So A is 6 through 9 here. Guaranteed. Hmm. So that means Y is at most 6. So the thing is, this difference, so this is guaranteed to be 0A and Z here, because this is blue. And remember, you can't have repeats on segments. So the thing is, A is equal to Y and Z and W. So Z and W could be 1 and 2. In which case, I guess, yeah. I'm just trying to look to see what happens if this is not A, right? Okay, so let's make that assumption that this is blue and this is green. These cannot be unique digits. So we have 0 and A here for these 3. So these have to be unique digits here. So it's Y with some sort of, I don't know, U, I guess. U and Y. Oh, but it can't be. If this is U and Y, we know these are 3 unique digits with 0, W, and Y, essentially. And we have A already in the row. So it would have to be U, so it would have to be W and Y is the sum of these digits. But again, we can't have 0, A, and Z, so that would mean WY equals W and Y here. Because A and 0 are already removed, this would have to be WY equals WY plus other stuff, which is not allowed. So this can never be blue. So this must be green, which makes this blue. So this is blue, which means this is blue to get in through there. We have one unique digit here. Y and X. Actually, we don't even know these. This can only be... So this is only 0. So 0, we have... The possibility is of 0, A, W, or Y here. So C is essentially W or Y. Assuming that if it's here. So this is Z, A, W, Y. Cannot be A. Because A cannot equal itself with other digits adding it together. So one of these is green, one of these is blue. We don't... Okay, this is a 2x2 area of all 3 greens, so this must be blue, which makes this green. Okay, so the blue extends out this way. This is A, 0AWY. We know A is equal to W plus Y plus Z. A has to be one of these 3 digits, so this can't be 0 or A. because again, you can't have repeats, so this must be some combination of 3 digits of 0, A, and Z. So if A is not here, we know Y plus Z plus W equals A. And this is only W and Y at most if this is not A. So therefore, we know, and this is guaranteed to have an A. So this has to have an A here. So this is Z, this is not 0. It's A with W or Y. We're not sure which. So again, Y, W, Y, and Z add up to A. So A is equal to A here. So we have Z and one of them. So let's make this a Y. So we'll make this Y, which means Y cannot equal Y plus Z, which is non-zero. So this has to be W. So we're going to mark that as W then. So this is W, this is A and Y. That means these must be 2 unique digits because we have only in these 4 cells 0, A, and Y. So this is... I guess we'll make it X and U. U and X. So this is guaranteed to be 2 unique digits, which are different from these in the column, in column 9. So this is guaranteed to be W. We have 0 and A here, which cancels A here. So Z and W equals Y. Oh, that's interesting. That means A has to be like 8, I think, or 6. Hmm. Yeah. These are 5 unique digits. We have already A and 0. This could be A and something else, so that's fine. What else do we have? One of these is Z. Okay. So Z must equals either be C, D, or E. We're not sure which. Okay. So we have Y equals, essentially, this is 0 and A. 0A Z. So the 0A cancel out the A. So that means Y equals W plus Z. A equals W, Y, and Z plus Z. So since Y is equal to W plus Z, the A must equal 2 times W plus Z, which is at least 3. So we're guaranteed a 1 in one of these, right? So A is 6 or 8. We don't know which. A is 6 or 8. And Y must be either 3 or 4. Okay. Um, hmm. A plus two other digits at least equals E. And so this can't be blue. If this were blue, it would be some combination of 0A and C. And we already have a 0A in that segment. So this cannot be blue. This is green, which means this can't be green. That's blue. This is C. So A, C, and D equals E. So A cannot be, A has to be 6. So A is guaranteed to be a 6. C and D must be 1 and 2. So since A is 6, Y plus W plus Z equals Y equals W and Z, and that's equal to 2 times that. So Y must be 3. So this has to be, so A is 6, so all the A's are 6. So this is 0, 6 as a combination. This is a 6, because it must equal the same digit here. One of this is some combination of 0 and 6. So this has to be 1, 2, and 3. So Z has to be 1 or 2. This must be 3, 6 as a pair. And this is 1 or 2 here. We have 1, 2. This is 0, 1, 2, or 3. 0, 1, 2, or 3. Whichever the other one is. So this is Z is 1, 2. This is 0, 1, 2, or 3 here. C and D have to be 1 and 2. So one of these is 1, one of these is 2. E is 9. So that means this is 1 or 2. Interesting. These are the same digits. So this is all C. This is D. So this could be 0. Can it ever be 3? No. So this cannot be Y. So this is 1 or 2 here. So this is 0, 1, 2, or 6. 0, 1, 2, or 6. This is, we don't have to worry about Z. This could be 0, 1, 2, or 6 also. Okay. This is definitely C. We have a 1, 2 pair in row 9. That means the remaining digits are 3, 4, 5, 7, or 8. Interesting. And 2 must add up to one of them. So we have a guaranteed 3 and 6 here. These are 2 unique digits. These all have to be unique digits. And they cannot be 0, 2, 3, or 6. So one of them could be 1. This can't be 1. So what are these unique digits? These are what? 3, 4, 5, 7, or 8. Obviously this can't. This is sums to 3 and 4. So this could be 3, 4, or it's 3, 5. Adding up to 7 or 8. So this is the same digit. So this is 7 or 8. So we're guaranteed 3 here. This cannot be 3. It couldn't be 3 anyways because that's 3 there. So 3 and 4 adds up to 7. This can be... So this can never be 8. If this were 8, the problem is that it would force that to be 7, and 8 plus another digit would not add up to 7. You can't have 2, 0, 2, 3, or 6 here. You could have 1. So 1 only adds up with 7 to add up to 8. You could have 4 here, but 4 at minimum would add with 5 to add up to 9, which is minimum there, which is not allowed because we have 9 unique digits which need to be in row 9, and they're all single digits. So this has to be 1 and 7. So this is 1, that's 7. This is 8, which makes this 8. So this has to be a 3-5 pair here. Okay. We have all 9 unique digits in row 9. This is 1. We don't know what combination that is. This must add up to 3 or 5. So this digit is some... Okay, it cannot be... 0, 1, 2. So this has to be some combination of 4, 5, and 9. We don't know which. And there are 2 unique digits here. We are guaranteed a 0 and a 6. So we only have 1 more unique digit in this row. Interesting. Okay. This is blue. So it adds up to 5. So this is 0 through 5 here. This is a value of 8. So this is a value of 8. This is a value of at least 3. So this is definitely 9 here. And it could be 4, 9 or 5, 9 here. This adds up to 7 or 8. Okay. These digits... Okay, so that means all of these digits must be 0 through 7. No, it could be 8. Cannot be 9, interestingly enough. So none of these could be 9. Huh. Interesting. That's not too helpful. Let's look at it. We have guaranteed in column 5 as guaranteed 0 and 6 and 9. We only have 2 other possible unique digits. Same with row 5. We have a guaranteed 0, 6, and 9. We have a guaranteed 1 out of 4, 5. So this is 0 or C, guaranteed. We don't know which, though. This is guaranteed 3. This is at least 13. Okay. Blue has to go out this way. That's interesting. So this is at least 4 digits. Can it ever be 5 digits? I think the answer to that is no. right? Because they have to be all unique because there are no repeats on this segment. So, and it adds up to 7 or 8, so these must both be green. Since both of these are green, one of this is green, the other one's blue. We're not sure which. This 2x2 area is all green, so this must be blue. To get out, this must be blue. So this adds up to 8 with blue. We could go out this way, we could go out this way. This is then green. The blue has to go out this way, so this is both blue. Interesting. Huh. That means this is 4 digits. One of these is blue. We don't know which, obviously, so we can remove the reds. One of these is blue. These could all be blue, technically. So there are no repeats, so this must add up to... So this is either 0, 1, 2, 4, 0, 1, 2, 5, 0, 1, 3, 4. So those are the possibilities. In column... Okay, so... In column 4, we are guaranteed 0, 6, and D. Oh, this must be 7 or 8 here. This is guaranteed to be a single digit because of the way that yin-yang works here. This must add up to 8. These two digits have to... Well... Technically, no. Right? It could be 6 and 7, technically. We have 2 unique digits here. This is a third in 4. Okay, so this is 1. We have a guaranteed 0, 6 here. We have a guaranteed 0, 0, 6, and 9. We have a guaranteed 7 or 8 here. We have a guaranteed 1 or 2 here. That means it has to be guaranteed 0, 1, 2, 7, or 8. Okay. This is not... This could be 0. This is the sum of at least 4 digits. Which could... Okay. No, this is the sum of 4 digits. We are guaranteed a 0 and 6 here. This is... I guess it could be 9 also. Yeah, I forgot. 9 can be here. So this is the sum of 0... Oof. We're guaranteed 0 and 6, so this is guaranteed to be 0 and 6 here somewhere. The other remaining digits we don't know. This could be a single digit if it's 9 and it's 0, 1, 2, 6, right? But we're not guaranteed this is not blue, right? So this could be blue here. This cannot be 9 here because 9 plus another digit is always going to be more than just 8 as a single digit. Or 7. But this is only 7 or 8 because this is 6 plus 0 plus 1 or 6 plus 0 plus 2. Because we have 6, 0, 6, 1, and 2 adding up to 9 here. We are pretty close. This must add up to at least 13. So since it adds up to at least 13, this is 4 through 9. It could be 6 and 7. So this is either 4949 or it's 5858. Wait, it cannot be 58. Okay, so what are the possibilities? If this is 4, this could be 49 and 49 added to be the same. 5959. Or it has to be, okay, so this is already 2 unique digits. We have 0 and 6 guaranteed here. So that means we have one other unique digit we can have. So that means this would be 6 and 7 or 6 and 8. Okay, so that's still the same combination. Okay, well, there's that. This adds up to at most 8. So this is 0 through 8. This adds up to 8, so these are 0 through 8 also. We're guaranteed a 9 here. Yeah, the Schrödinger cell makes things a lot more complicated, I will say. We have guaranteed 0 and 6 here. We don't know what the other digits are. This could be 0, 6, so let's just remove these so that we don't get completely confused. Actually, I guess this one we should keep. This can only be 4 digits. It could be 0 and 6 also, so that works fine there. So row 1 has 1 unique digit, column 1 has 1 unique digit, row 2 has 2 unique digits, so does column 2. Row 3, we haven't differentiated the unique digit. We have to figure this part out. So this is at least 9, but that means it could be green here. This could be 3 or 4, I guess. We already have 3 guaranteed unique digits here. I mean, this could be a 4th. 9 is not here, because 9 has to be here. Oh, hold up. This is 3 unique digits, and we know this is at least 4 and 9 here. Dang, okay. Wow. That means this must be a blue. This has to be a blue because this is a single digit here. And it must be a single digit here. So, yeah, I totally missed that. These are 3 digits, and this is guaranteed 13. Or 4 digits, I guess, at least. With a 9 guaranteed and at least a 4. That means this is 0 and 1 at minimum. So this has to add up to at least 14. This can be at most 17 here. So this is at least 14 also. This is guaranteed to add up to at least 3. This is guaranteed to add up to at least 8. So this is 11 at most here. Sorry, at 11 at minimum. So this must be 0 through 6. So these are 3 blues in 2x2 area, so this must be green, which makes this an 8. So this is an 8, the same. Blue must go out this way, so that's blue. So this is at minimum now 0, 1, 2, 4, and 9. Interesting. 0, 1, 2, 4 is 7, plus 9 is 16. So this has to be 9 guaranteed here. So 9 is guaranteed here. This is also 9 guaranteed here. This at least, yeah. Can you have 3? Oh, well, we have to. Whoa, that's problematic. That's not going to work. That doesn't work. We have 6 unique digits here to add up to 2. And one of these has to be... Oh! Never mind, this doesn't have to be 9. It has to be 4, 5. Okay. That... Okay, let's go back. Let's go back. This, though, does have to add up to 3 plus 8 at least. So therefore, this is at least 2 unique digits. So we know that's blue, which means this has to be green, which means this is an 8. Because this is an 8, this has to be blue here. This must connect out this way. This is blue. These 3 digits in this 2x2 area are blue, so this must be green. These 3 2x2 area are in this. These 3 cells in this 2x2 area are green, so that must be blue here. This is a blue diagonal here. It must connect to, so this is blue. So one of these is blue and one of these is green. We're not sure which. But these 3 digits, okay, so this is not guaranteed to be 9. It cannot be 9, actually. This has to be a 4, 5. Fascinating. So this is at minimum 6 unique digits, which adds up to 15 at least. So we have 4 and 5 here. Okay. That means we have 0, 6, and 4 and 5 here. We have to have only one other unique digit in row 5 because we are guaranteed this is 4 or 5. Because if we try 9, that does not work. We have 0, 1, 2, 3, 4, 9 minimum, which adds up to 19, which 2 digits can never add up to. So this has to be 4 and 5. So that means to add, this is minimum adding up to 15. That means we have one other unique digit possible here, so it has to be 6 and 9. So this becomes 6 and 9. This then cannot be 1 or 2 or 7 or 8. This has to be 0, 6, or 9 here. This is 0 and 6 with 2 other digits. So these are some combination of 0, 4, 5, 6, 9 in row 5. That means this must be 15, so this must add up to 15. It's 6, 7, 8, or 9 here. We don't know. These must be 0 through 3. So we're guaranteed in row 6, the digits 0 through 3 and 6. So we have one more digit remaining here. This could be 6 also. I don't know why I did lift that out. Again, remaining digits in column 5. We are guaranteed 1 out of 1 or 2, a 6, a 0, a 9, and then a 7 or 8. So that eliminates 4 and 5 here. So 4 and 5 cannot be here, but it could be 0, 6, and 9. You could have 0. No, this is 4 unique digits. So you cannot have. You would have 0, 6, 1, and 9 at minimum if this is 9. So this cannot be 9 here. This is blue. So this is 15. And these are single digits. This has to be 6 and 9 then. 6 and 9 here. We have 7 unique digits here. Okay. This adds up to 8, adds up to 8. So one of these is blue, one of these is green. We're not sure which. So this can, okay. This could be 0 and 6 here, and this could be like 1 and 2 still. This is 6. Okay. How many unique digits do we have? This is 3. This is 2. We have 3 here. 4, 5. We need 3 more unique digits. In column 8, right? We have 0, 6, 1 out of the 1 or 2s, 9, and 8. We are guaranteed this digit cannot be both 4 and 5. So only 1 out of 4 or 5 is here. So this must be 2 unique digits here. Right? We have 5 unique digits in column 8 in 7 cells. So the 2 remaining cells can only have 4 unique digits at most. I guess this could be 2 uniques here. If this were 3, that would guarantee this is 2 unique digits. So that would not guarantee 2 unique digits. We have to have a 4 or a 5. It's not true. We don't have to have either. Oh. What happens if this is 5? If this is 5, how many unique digits do we have in row? Okay. Row 8, we are guaranteed there's no 9 here. Can this be 9? Maybe. Oh, this is rough. Okay. So it's trying to figure out how many unique digits we have. This could be many things, so this is not helpful. This is 15 guaranteed. This is 8. So either this is 3, which would make this 4 in value. This is blue. Right. We don't necessarily need a 4. Oh, we don't have access to a 7 in column 8. None of these could be 7 because of the sums. This can't be 7 because of we only have 5 unique digits in row 5. These have to be 0 through 3. And 7 can't be here because it's either 3 or 5. So we're missing a 7, definitely, in column 8. We also only have access to 4 and 5 in this cell. So this one of these cells must be 4 or 5, which means this must be 5 here, and this must be 3. So the value of this is 5. The value of this is 8. That means this value has to be 2. So this is 0, 1, or 2 here. So this is 4 or 5, which means it's 0 or 1 here. I think this has to be a 3. We don't have 3 anywhere else in the column, so yeah, that has to be 3. And this is 1 out of 4 or 5. This must add up to 2. So it has to be 0 and 2 here. It can't be any other combination. So this is 0 and 2. We have a 3. We have 0 and 2, 3, and 6 guaranteed here. So this has to be a 3 here. And can you have 0 here? 0 and 3. No, you have to have the other one. Oh, I guess you could. Okay, again, you have 6, 0, 1 out of 1 or 2, 9, and 8 guaranteed. That's 5. Okay, yeah, that's set. In column 7, there's a lot of possibilities. Anyways, this is 15. This is a single digit. Oh, yeah, you have 4 digits. One of these is 0. You have 0, 1, 2, 4, 1, 2, 5, or 1, 3, 4. We're not sure which. We have 7 unique digits here. We have guaranteed 0, 6, and 8. 0, 6, and 8. There's only one more unique digit here because we have 3 guaranteed. One of these must be 0 or 6. Or it could both be 0 and 6. 2 unique digits here. possible. Ugh. Trying to keep track of all the unique digits is kind of hard. Hmm. Okay. Oh, wait. Can you ever have 4, 5, and... So you could have 6 and 9, I guess. You can't have 4, 5... We're guaranteed a 1 and 2 in column 4. We are also guaranteed 0 and 6. We have one other unique digit in column 4. So this is guaranteed to be 0, 6, 1 out of 1 or 2, and the remaining digit. If you have 4 and 5 here, that would add up to either 0, 1, 4, 6, which is 11, 0, 1, 5, 6, which is 12, 0, 2, 4, 6, which is 12, or 0, 2, 5, 6, which is 13. So this can never add up to 13 because, again, you have 0, 4, 5, 6, 9 here. We already have a 1, 2 guaranteed, a 6 guaranteed, a 0 guaranteed, and a 7 or 8 guaranteed. So this can never be 4 or 5. Therefore, this would never add up to 4, 11, 12, or 13 because we only have 0, 6, and 9 available. And that adds up to either to 6, 9, or 15. So this cannot be 4 or 5. This has to be a 0, 6 pair, which means we have one of the 1 or D here. So 1 out of 1 or 2, and then the last digit, which we don't know. But it can't. The last digit cannot be 4, or can it be 3 even? No. It can't be 3 because... So it must add up to 6 or 9 or 15. Well, it can't add up to 6 because we have 0, 6, and at least 1. So it's either 9 or 15. So we have a guaranteed 9 here. 15 would mean 1 and 7? So the point is that you can never have 3 here because 1, 3, and 6 adds up to 10, 2, 3, and 6 adds up to 11. And that can't sum to the same sum as this. So this can never be 3. We know where the 3 is then in row, on this equal sum line. So this is 3. It could, so that means this can't be 3, 4, or 5. This has to be then a combination of 0, 1, and 2. That makes this... Okay, so then this has to be 0, 1, and 2, and it's then adding with 5 or with 4 to add up to 7 or 8. We are guaranteed this is 0, 1, 2 because there are no repeats again along a segment. So this is... So it could be 7 or 8 here to add up to 6 or 9. This is 0, 1, 2, or 6. We don't know which. So this is 3. These have to be different digits. Okay. We're guaranteed a 9 here. This could be 7 or 8 with 1 or 2 to add up to 9 and 6 to add up to 15. Or it's 1 and 2 with 1 and 2 and 6 to add up to 9. So we just don't know. It's 1, 2, 7, 8 here. So the remaining digits in column 4 have to be 0, 1, 2, 7, 8. How many unique digits do we have? So say, oh, it could be 6 also. Right, 0, 1, 2, 6, 7, or 8. This is 4 or 5. We don't have 3 available at all in row 7. We have only 1 out available out of 4 and 5. That limits 2 digits already. If this were 8, okay, so this can't be 4, 5, or 9. This is 0, 6. It cannot be the other 1 or 2 here, so this is 0, 6 guaranteed. Okay. This is C, C, C. We are missing a 3 in row 7. We are missing 1 out of 4, 5, guaranteed. If this is 6, 9, I think this has to be 7 here. If this is 7, 8, so say this was 7, 8. We're missing a 9. Okay, that works. Huh. Okay, column 7. We are missing, we have a guaranteed 0, 6, 9, and 5. Oh man, this is so complicated. This is 6 and 9. That's fine. This is 0 and 2. How many digits do we have in column 6? These are 2 unique digits adding up to 7 or 8. We have 3, 1 out of 4, 5. 0 and 2, definitely. So 3, 1 out of 4, 5, 0 and 2, and 6. So that's 5 guaranteed digits. Ugh. Oh, this cannot be both 1s and 2s here. Can it? Or it could be. It could be. Never mind. Never mind. So that could be 0 here. I don't know. Hmm. So there have to be 3 unique digits between these two cells. Um, there are at most 4 unique digits amongst these cells here. And 1 more here. So that's right, 0, 1, 2, 6, 0, 1. So that's 4 with a 5th one. That means we have 5 only guaranteed unique digits, or 5 digits uniquely guaranteed amongst these cells. So if this is not 7 or 8, 0, 1, 2, 6 is going to be non-unique. And you can only have 2 unique digits here. So that would be 7 in row 8. So this has to be a 7 or 8 here. So this cannot be 2 and 6. This is definitely 7 or 8, which means the other digit must be 7 or 8 in column 4. Because we need a unique digit here. And then these two have to be unique digits. So it cannot be 0, 1, and 2. Can't be 6. Has to be some combination to add up to 8. So this cannot be 7 or 8. Again, we need 1, 7, or 8 here. This must be 3 with some 4 or 5 here. So this has to be blue to add up to whatever this 15 is. So this has to be 6 and 9 here. This must be 6 and 9 to add up to 15. We have 4, 5, 4, 5, 6, 9, 6, 9. Therefore, these are blue, so this must be green. So this has to be the same 7 or 8. This is blue. This must be 3 and 5 adding up to 8. So this cannot be 4. This is 3 and 5. We have, again, unique digits. We have 0, 1, 2, 6. 0, 1, 2, 6. 3, 5. It would have to be the other 4. And it would have to be 1 out of 7 or 8, which is here. So this is guaranteed to be 1 and 4, because we need the 4 here to add up to 5. So this is 3, 5. So this is 7, 8. It could be the same 7, 8 here. Okay. It has to be the same 7, 8 here. So this cannot be 0 and 6. If this is 0 and 6, this would never add up to, you could never have a 7 or 8 here. So it has to be 1 and 6 with 2, 1 and 6 or 2 and 6 with 0, 7, 0, 8, or 1, 7 here. What happens if C is 1? Ugh. Actually, what happens if C is 2? If C is... I don't know. How many unique digits do we have in column 7? We have 0, 6, 9, 5. It's not helpful. How about unique digits in column 6? Well, we have 0, 6, and 9, 3, and 2. That means the 4, 5 is the last remaining unique digit. So this cannot be any of the other digits. So there's no 1. There's no 7 or 8 involved. And it could be any of 0, 2, 3, 4, 5, or 6. Interesting. Huh. So this can never be 0 then. Because if this were 0, it only can add up with 7 or 8 to add up to 7 and 8. So this can't be 1. Okay. So again, we have 9, 6, 2, 9, 6, 2, 0, 3, and then the 4, 5 that's remaining here. So either this is 2, 6, which adds up to 8. 2, 6 works. 3, 5 works, because then this would be 5. 3, 4 works, because that would be 4 then. And we're guaranteed a 3 here. So this is 4 and 4. Oh man, this is so complicated to try to get these unique values. Ooh. Okay, we know this is 6 plus C. That adds up to whatever this digit is. Well, actually, what doesn't add up to that digit? Ooh, not guaranteed. Hmm. Jeez. This could be 0, 6. So this digit is the same as this. It's different than that. Okay, so let's start marking those then. Maybe that will help. So this, I don't know, we'll make this pink and this one orange. So these must be, one of these must be orange. Pink has to be one of those two, but we don't know which. If this is orange, that would mean this is 0. That's fine. This pink has to be either the same as this. Oh. Okay, so these are orange, these are pink. This, if it is 1 or 2, is pink. These we're going to make red, I guess. This is yellow. Yellow cannot be here, so this is the red 1, 2 here. This has to be the yellow 1, 2. Because, and this can't be, yeah, this can't be both 1, 2s now. Because we know this has to be 7 or 8. Because we needed that unique digit here. So that 7 or 8 has to be the matching that. So these are all yellow. Since this is yellow, this can no longer be yellow, so that's pink. So yellows are the same as orange. So yellows are the same as orange, and the reds must match. Red has to be pink. So these are all pink, and it matches this. So this cannot be pink or orange. It has to be 0. So this is 0, which makes this the orange 1, 2. Okay. What does that mean? I don't really know. Hmm. We do know this is 0. That's not that helpful. Again, so pink. Oh, interesting. Okay. So say pink is 1. Say pink is 1. That means this is 106, so this would be 7. Orange would have to be 2, and 2 would be adding with 7 to add up to 9. So these would be the same 7, 8 digit. Say this was 2, then. You'd have 206. Oh. Then this would be, well, guaranteed 1 and 2 now in row 7. 6. Sorry, 6. Because if this is 2, that means this has to be the orange one, and this is the orange 1, 2. So we have guaranteed the pink and the orange here. So that's guaranteed 1 and 2. We have 0, we have 6, we have 3, and we have a 7 or 8. That eliminates 4 and 5 as possibilities. So this must be 2, 6 then. Because, again, in column 6, we already have all the unique digits also. So we are eliminating 4 and 5 because we have all the unique digits already in row 6. We have all the unique digits in column 6. 3 and 6 don't add up to 7 or 8, but 2 and 6 does. So this is a 2-6 pair, which adds up to 8. That makes this 8. That means this adds up to 8. So C, the blues are 2. So this is 2, these are 2, this is 1. That makes this 1, that 2, this 1. This has to be a 0, 2, 6 triplet. We don't know which one's which. This is 1, so this cannot be 1. That forces this to be 2. So this is 2, 0, and 2. This has to be 2 and 6, which means it's 0, 8, 1, 7. This is the orange, so it has to be 1 and 8. Therefore, this has to be 0 and 8, adding up to 2 and 6. This is 0 and 1. So those are all done. This cannot be 2, so it has to be 0 and 6. So this adds up to 15, 15, 15, 8 and 8. This must be 0, 1, 2, and 5. So we have how many unique digits in row 7? 0, 6, 2, 1, 8, and 5. That's 6. So it either is 7, 8, or 6, 9 here. How many unique digits do... Okay, so... Unique digits in row 1, 1, 6. Digits in row 2, 0 and 6, 2. Unique digits in row 3, 0, 2 and 6, 3. Unique digits in row 4, 0, 1, 3, 6. That's 4. Unique digits in row 5. We have 0, 4, 5, 6, and 9. That's 5 unique digits. Unique digits in row 6. We have 0, 1, 2, 3, 6, and 8. So that's 6 digits. 7 digits in row 7. So we have, this is set. Unique digits in row 8. We have 0, 1, 2, 3, 4, 5, 6, and 8. That's 8 unique digits. We have 9 unique digits in row 9. We already figured out row 7's fine. Column 1, 1 unique digit, 6. Column 2, 2 unique digits, 0 and 6. Column 3, 0, 2 and 6, 3 unique digits. Column 4, 4 unique digits, 0, 1, 6, and 8. Column 5, 5 unique digits, 0, 2, 6, 8, and 9. Column 6, we have 0, 2, 6, 0, 2, 3, 5, 6, and 9. So that's 6. Unique digits in column 7. Okay, the unique digits in column 9. Let's just make sure that we have that. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's 9 unique digits. Column 8. We have 0, 1. We need to have a 2. So 0, 1, 3, 4, 0, 1, 3, 4, 6, 8, and 9 only is 7. So we have to have a 2 here. So this is guaranteed to be 2, which means this is guaranteed to be a 2, 3 pair. So this is 2 and 3, which means this is a 0, 1 pair. Okay. In column 8, column 7 then. We are guaranteed 0, 1, 6, 9, 5. So 0, okay, 0, 1, 3, 5, 6, and 9. That's 6 unique digits. If we have 7 and 8 here, that's 2 unique digits, which is not possible. So this has to be 6, 9. So 0, 1, 3, 5, 6, and 9. That's 6 unique digits. We can't add 7 and 8 because that would be 2 digits too many, or 1 digit too many. So we have to have 6 and 9, which means this must be a 2. And that's, yeah. To do, figure out what GDC usually does with solution messages and add it here. Maybe something about octuples or anti-rook. Doesn't really fit, though. Oh my god, that was crazy. So this was 0 and 6 then. Okay. So we can remove the pinks. This was crazy. Wow. I would consider this very hard. But this is the final solution. Oh man, that was difficult. That was difficult. A lot of assumptions that we had to sort of unwind about that. So maybe it's a little bit more easier for people who don't have those Sudoku assumptions. That was pretty crazy though. Yeah, fun puzzle, but man, that was hard. Just wrapping around my mind around essentially everything was really difficult. So that was just tough in general. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.